We're in New York Blower's test chamber, where sound and performance tests are conducted. Because fans are rotating machinery that impart energy into the air to get it to move, one byproduct is sound. Now, with this axial fan test setup, we're going to simulate several different scenarios. The larger the fan, the higher the speed, or the higher the volumes and pressure, and the higher the sound level. Listen to the sound generated by this axial fan operating first at 1,000 RPM. Now listen to that same fan at 1,600 RPM. If sound levels appear excessive in your installation, several areas require investigation. By just listening to the sound, most sources can usually be identified. Take the simple things first. Check for loose components, accessories, belts, or worn bearings. Next, look for vibration elsewhere in the system. Vibration is a major source of system sound. We'll talk more about vibration in the next section. Support structures are always prime candidates for generating vibration and sound. Structures must be rigid and the fan securely attached to them. If the noise seems air-related, review the connecting ductwork. If there are any obstructions or sharp elbows at the inlet or outlet, the air turbulence caused by these items greatly increases the noise level. If the fan is operating near its stall or surge region, this will greatly increase the inefficiencies of moving the air and the corresponding noise level. The sound generated in this situation usually exhibits strong aerodynamic pulsations accompanied by housing and duct vibrations. It sounds like this. Nearby reflecting surfaces, like the walls, floors, and ceilings in a hard room like this, or other machinery, can raise the noise level by trapping the sound waves in a confined area. Now let's get back together with Matt. I think he's just the one to help us address the issue of vibration.
Vibration is a common occurrence in the industrial environment, and air-moving systems are no exception. New York Blower balances every wheel and test runs every fan prior to shipment. However, there's many factors during shipment and installation that can induce an excessive amount of vibration.
That's really true, Matt. In fact, that's something that we don't have control over. For instance, during shipment, installation, and initial operation, mounting bolts, duct connections, set screws for drives, wheels, bearings, and bushings can loosen. Now, it's a simple procedure to inspect the fan and tighten all belts, screws, bushings, and the like to eliminate them as a vibration source and as a sound source, too.
That's right. You need to inspect all the drive components, such as the belts and shivs looking for excessive wear, and bearings and couplings looking for misalignment. This diagram shows how to check for coupling alignment. Adjustments can be made by moving the motor to change shaft angle and by the use of foot shims to change the motor shaft height.
Now, Matt, I understand that another common cause of vibration can be misaligned or unbalanced motor shafts. Misaligned motors and drives are usually characterized by high axial vibration, isn't that right?
That's exactly right. To test motor vibration, you need to remove the belts and run the motor by itself. The vibration still exists, remove the drive shiv, and if it goes away, that means that it was the shiv that was out of balance or misaligned. But if vibration still persists with the motor, then you need to contact the motor vendor or a motor service center.
Okay, I get it. That's a good idea and a good procedure to follow, I'd say. Now, Matt, we should also point out that on occasion, excessive vibration is caused by a bent fan shaft. Now, this is usually the result of mishandling during installation or system shutdown. A bent shaft can also result from material impact to the wheel. Now, Matt's going to use a dial indicator here to identify if the fan shaft is bent. While slowly rotating the assembly by hand, he measures the shaft's straightness or overall runout. The shaft should be straight within a 2,000th for most fans and within 1,000th for higher pressure fans like the Series 45, Series 60, RTS, AF40, and pressure blowers. One of the more common causes of vibration comes from the accumulation of foreign material on the wheel. Now, normally material accumulates on the wheel uniformly. It isn't a problem until a chunk loosens and comes off, causing the wheel to go out of balance. For some applications, wear or erosion of the wheel can be the cause of fan vibration. Now, this is especially true in material handling applications or systems with corrosive gas streams. In a sense, this is just the opposite of the material buildup problem. Here, a reduction in weight causes the imbalance. Vibration can also occur if the airflow is restricted. This could be caused by a difference in the pressure requirements of the system or restrictions in the system, such as closed dampers. As we discussed with sound, these system changes cause the fan to ride the fan curve and possibly position the fan's operation in an unstable area.